从我记事起，家乡就是一片沙漠。老人们常说，沙漠再往前走，家就没了。18岁的时候，出去上大学，离开了家乡。他们知道我是从内蒙来的，就会问我：“你们从小是不是在草原上骑马长大？”我会告诉他们，我们那边只有沙漠，没有什么草原。我是19年回来的，爸妈年纪大了，想回来照顾他们。刚好这边电站建好了，有适合我的工作。我在电站干检修工作，像一个医生一样，发现问题要及时处理。哪有问题了呀？
那边电阻是吧？
测一下那个电流。这泄松了，我保一下。我这边电流恢复正常了。
稍等，我这搞恢复自动。
好，去下一个地方。
库布齐沙漠呀，相当大。过去今天吹下倒好，明天就是一条整个大沙丘。沙丘是绝北绝高，是这好是绝天绝上，要是风天好，沙北凉。看这个地方。
有4个月了，计划还有多长时间才能铲平完的这个？大概？
那边有一个。
沙漠是一个非常适合建设光伏电站的地方。光伏收益只是一方面，电站的建设会对周边的环境和老百姓起到了一个非常良性的改变。作为这个电站的员工，我感到非常自豪。未来我们会持续治理这片沙漠，用我们的努力去更大范围地改变它的环境。
有了光伏板之后，它大大的降低了风速，也起到了遮阴的作用，减少了水分的蒸发。我们这儿现在不止长出了黄芪，也可以种植各种各样的瓜果蔬菜。过一段时间，看能不能把他们园卖出点儿，然后想把他们房子这些修一修。我爸妈种了一辈子地，也没琢磨过生活还会有什么变化。现在挺满意的，主要是对我挺满意的。我现在就是干好我的本职工作，做一件很小的事情，也是在为家乡尽一份力。
新技术、新设备，还有新方法，说到底，都是对我们人的力量的一种辅助。都说我们是3毫米、3毫米的改变这里的土地，滴水穿石，变化就是这么一点点的出现的。
我也希望将来有一天，有人问起我的孩子，你们内蒙人是不是从小在草原上骑马？我想告诉他，你说的对，我们这儿的马终于从沙漠里跑到草原上了。
我们石营村是广东省连州市的一个小山村，以前啊，这里一大片都是荒废的山头，经济比较落后，很多人都被迫到外面打工了。2019年，我们村引入了200兆瓦的人光互补光伏发电项目，不仅可以发电，光伏板下还能种植玉竹，一地两用。带动村民增收的同时，还创造了很多就业机会。以前的工作在工地做嘛，在工地做活也比较累一点，一个月才做的10天8天这样子。后面我就回来了嘛，他这里比较稳定，每天都有事做，下了班回去可以跟小孩子玩一下嘛，是吧？在家里做起来也觉得挺开心的。
这个玉竹呢，石英在光伏区种啊，它有2个优势，一个可以遮阴，另外一个呢，它中间起到一个通风透气，有利于这个玉竹的生长。今年跟这边公司合作种植了大概有1000多亩，为本地提供了大概有150个工作岗位吧。
农业与能源的共生，科技与自然的融合，让石营村以绿生金，照亮了石营村经济发展、保护生态的乡村振兴之路。
光伏行业是一个新兴的行业，相比传统能源呢更清洁、更环保。光伏板的铺设避免了强光直射，一定程度上减少了土壤水分的蒸发。后续我们还将引进金银花、白芍等中药材，希望通过持续改善土壤、丰富种植品种等方式，给村民带来更多的经济收入，助力乡村振兴。
守望乡土，瞭望未来，在山林之间穿过一道道光，让每一个农民都绽放笑脸，让这片土地的生息回归土地之中，让科技与自然共生。
Hello everybody, my name's Ollie. We are here at Aquila Game Reserve in the province of Western Cape, South Africa, where we're hoping to see the big 5 animals that live here in the wild. I hope you're as excited as I am. Let's go.
One of the main differences about this reserve to other reserves is that most of the animals here have been sort of saved, and that's the case with the elephants. Those elephants were at a different reserve and they were going to be culled, so they've been brought here.
Would you mind telling us a little bit about how Aquila is taking them in and taking care of these animals?
Yeah, what basically happened with these lions, you know, we as Aquila are completely against all these can hunting projects. We actually giving them their space, so they're actually quite happy, quite chill with us people.
Yeah.
Those rhinos are huge. Holy moly.
They look like they could do
They're massive, aren't they?
Actually 4 of our rhinos actually got poached, and the female basically went through constructive facial reconstructions, because with the high caliber that they basically used to basically kill the rhinos.
The most social animal of the big 5, in fact, collating in groups of up to 2,000 in the wild.
But they are actually one of the most dangerous animals you can actually find, especially on foot.
Wow.
They walk towards you like they don't care, and then they tend to ambush humans actually as they walk past them.
Whoa! Look at that, it's literally left a cloud of dust behind as well. It's not every day you get to see a cheetah running just how it would in the wild.
What this is all about is that they previously used to use a diesel generator, but diesel generators are dirty, they're noisy, they're smelly, and this solution here that Huawei have provided, it's a total eco-friendly clean energy solution. In the not too distant future they're going to expand the solar solution to the whole park and all the lodge where we stay in.
To see how Aquila is harnessing the sunlight here in South Africa to power the reserve, and they really are becoming at one with nature. It's been very special to see.
Established in 2021, Huawei Digital Power
Distinguished guests, good afternoon. Thank you for attending the launch of Top 10 Trends of Smart PV 2023. It's a pleasure to meet you via the cloud. With a global consensus reached on carbon neutrality, PV has become the main source for countries to seek energy transformation and build new power systems, and is under great expectation. The explosive growth of PV industry generates both opportunities and challenges. What are the changes and directions of technological innovation of the smart PV industry? Next, let's invite Mr. Chen Guoguang, President of Smart PV and ESS Business, Huawei Digital Power, to unveil the top 10 trends of Smart PV 2023. Dear customers, partners, and industry colleagues, I am Chen Guoguang, President of Smart PV and ESS Business Huawei Digital Power. Welcome to the launch of Top 10 Trends of Smart PV 2023. The launch of Top 10 Trends is based on Huawei's insights into the smart PV and ESS industry, third-party forecasts, and customers' judgments, and is based on modeling and analysis. According to the report released by Amber, an independent climate think tank of UK, in 2022, to achieve the global temperature control target of 1.5 degrees Celsius, wind and PV power generation need to maintain an annual growth rate of 20% by 2030. Major regions of the world have proposed clean energy development plans for the next 5 to 10 years. China and Europe have released the 14th five-year development plan for renewable energy and Repower EU, respectively, proposing new and more clear plans for new energy development. According to the forecast of IRENA, the installed PV capacity will reach 5,200 GW in 2030 and 14,000 GW in 2050. PV will become the main energy source. Facing the rapid growth of the PV industry, there are still many challenges to be addressed. First, how to continuously reduce the system LCOE and LCOS. The rapid growth of the PV industry relies on the continuous reduction of LCOE, LCOS. How we will continuously reduce them and accelerate the deployment of PV plus ESS systems in more areas and scenarios to achieve business closure. Second, how to improve O&M efficiency. More utility-scale power plants are being deployed, many of which are in remote areas, which creates great difficulties to O&M. In a distributed scenario, management of scattered power plants and security remain challenges. Third, how to improve power grid stability and power consumption with high proportion of PV. With the increasing proportion of new energy, the stability of the power grid is affected. Many countries and regions with a high proportion of new energy, such as Australia and the UK, have experienced large-scale power outages caused by the disconnection of new energy from the grid. Therefore, how to maintain the power grid stability while improving new energy consumption is a challenge facing the industry. Fourth, security is the cornerstone of the industry. In recent years, safety accidents of PV and ESS stations have occurred, especially with the power of PV and ESS equipment keep increasing, and as rooftop PV and campus residential ESS become popular, ensuring end-to-end system security has become a major challenge. Challenges and opportunities always coexist. To address the preceding challenges, Huawei has identified the Smart PV Top 10 Trends: PV-ESS Generator, High Density and Reliability, Module-Level Power Electronics, Smart String ESS, Cell-Level Refinement Management, PV-ESS Grid Integration, Upgraded Safety, Security and Trustworthiness, Digitalization, and AI Application. Next, I will share Huawei's perspectives on them each, and I look forward to discussions with you. Through Trend 1, PV-ESS Generator. Through PV-ESS convergence and grid forming, intelligent PV-ESS generator will be built, and the control mode of new energy will be changed from current source to voltage source, with strong inertia support, instantaneous voltage regulation, and fault ride-through, thereby improving active and reactive power control and response. Frequency and voltage fluctuations will be proactively mitigated. This will be an important measure to improve power grid stability and PV consumption, shift PV power generation from adapting grid to supporting grid, and put PV on a fast track of becoming the main energy source. In 2021, the SGCC Qinghai, CETC, Tsinghua University, Zhejiang University, and Huawei set up a dedicated research team to carry out a study on secure and stable operation of power system with high proportion of renewable energy, supported by large-scale energy storage systems, and proposed optimal power allocation and control strategy through grid forming, which provided a new technical means to unleash the capacity of new energy generation and HVDC transmission. In 2022, Aquila Power and the SEPCO 3 partnered with Huawei to build the microgrid project for NEOM, Saudi Arabia, the world's first city that is powered 100% by new energy. The project consists of 400 MW PV and 1.3 GWh BESS. It replaces traditional diesel generators and provides clean and stable power for 1 million people. It is also a practice of great significance of achieving 100% clean energy supply for the whole world in the future. Trend 2. High density and reliability. In recent years, the LCOE of traditional fossil energy has been rising as a result of resource depletion and carbon tax, while the new energy economies have shown great prospects. According to IRENA 2022 report, the LCOE of PV has dropped by nearly 10 times over the past decade, and is now lower than that of traditional fossil energy. Technological innovation of PV has accelerated the reduction of its LCOE and also the replacement of traditional energy sources by PV. High power density, the reduction of PV LCOE depends largely on the increase of power density. The power density of subarrays has increased from below 1 MW to over 3 MW or even 6 MW. The power density of modules has increased from 300 watt to over 600 watt. The power of inverters has increased from around 200 kW to 300 kW. Meanwhile, with the rise of high-density materials such as silicon carbide and gallium nitride, the power density of inverters is expected to increase by an additional 50% in the next 5 years. High reliability. After power density is improved, high reliability becomes even more important. Magnetic integration, power distribution board integration, air duct optimization, modularized design, and independent cabin design will ensure high reliability of the system. In addition, verifications are carried out in all scenarios, including level 12 typhoon and high salt fog, to ensure high availability of products in harsh environments. After 4 years of R&D and testing, our intelligent string inverter has achieved high reliability with high power. The UHV project in Hainan, Qinghai Province is a 2.2 GW PV station consisting of 9,216 devices that operate stably in harsh environment at 3,100 meter altitude. The service duration of inverters reaches 20 million hours. System availability reaches 5 nines. This ensures high yield and reduces LCOE. Trend 3. Module-level power electronics. In 2021, the added install capacity of distributed PV has accounted for nearly half of the total added install capacity, and will maintain nearly half for this year and years to come, which presents huge market space. However, with the rapid growth of the total installed capacity, high-quality rooftop resources are increasingly scarce, so optimal adaptation to rooftops is the most important need in the future. Distributed PV is closer to people's lives and requires higher security. Distributed deployment also makes O&M more difficult. We believe that distributed PV will gradually shift from the wild growth of installed capacity to refined power monitoring, which is supported mainly by the MLPE technology, namely module-level power electronics. In PV systems, MLPE refers to power electronics devices that can perform refined control on a single or several PV modules, including microinverters, power optimizers, and shutdown devices. MLPE's unique values include module-level power generation, monitoring, and shutdown. Looking back at the history of PV devices, it can be found that the change from centralized to string-type inverter achieved the upgrade from system-level to string-level MPPT, with an increase of system yield of over 3%. The rapid development from string inverters to microinverters, or the MLPE solution, has enabled the PV system to optimize power generation and monitoring at the module level, further improving the overall yield and security. In the future, it may evolve towards separate optimization module, that is, monitoring and optimization of yield at a sub-array or cell level. The granularity of PV yield management is gradually refined, and the more granular management of PV system will lead to more intelligent power generation and greater security.
Trend 4. Smart Stream ESS. Just as the transition from central inverters to stream inverters for refined management, stream ESS will also become the way to go, with higher usable capacity and better safety. Traditional centralized ESS consists of over 2,000 battery cells connected in series or parallel. It's difficult to implement refined charge-discharge and temperature management, which results in waste of capacity. Smart Stream ESS adopts a stream-based, intelligent, and modular design. A battery pack optimizer is used to realize full charge and discharge of each pack. A rack controller balances the capacity in charging and the discharging process, avoids inter-rack cross-current, and improves the available capacity. Distributed intelligent temperature control enables even heat dissipation to better manage temperature. What's more, advanced digital technologies such as AI and cloud BMS can accurately identify internal short circuits and issue timely warnings of potential fire hazards. AI technologies are used to build prediction models to evaluate cell health, battery life, and reduce initial battery configurations. Last but not least, a modular design is adopted. If a single pack and PCS become faulty, other modules and PCS will not be affected. Spare parts support plug and play, which improves the system's usability. In 2022, Huawei and partners jointly built a 200 MW, 200 MWh energy storage plant in Singapore, the largest ESS in Southeast Asia. For frequency regulation and spinning reserve, the Smart Stream ESS uses its leading stream technology to provide constant and stable power output and produce more benefits. In addition, the automatic battery SOC calibration function reduces labor costs and greatly improves O&M efficiency. In a new project, the world's first gigawatt-hour level off-grid ESS with 100% new energy power supply, the Smart Stream ESS uses distributed temperature control to ensure reliable operation in high-temperature environment. Pallet transportation is boarded, installation and cables connection are not required on-site, reducing the construction time by more than 3 months. Trend 5. Cell-level refined management. In the past 2 years, a couple of accidents happened with ESS. One major cause is internal short circuits as a result of lithium plating, leading to thermal runaways, which is not easy to be detected. How to detect potential safety hazards and issue early warnings is a challenge that must be addressed. Just like the adoption of MLPE in PV systems, the management of lithium battery ESS are bound to be of finer granularity. Only with cell-level refined management can we address the challenge of balancing efficiency and safety. The BMS management system needs to be more sensitive, more intelligent, and even being able to predict. That requires the collection and processing of a large amount of data and using AI to find a sweet spot and make predictions on trends. Traditional BMS can only collect and analyze a limited amount of data. Early detection and warning is almost impossible. Cloud BMS will enable fast computing of massive data. With AI algorithms and models, the cell status can be effectively monitored and predictions can be made. Based on Huawei's cell puncture test data, Cloud BMS can provide a thermal runaway warning 24 hours in advance to avoid greater losses. Related technologies have been verified in driving scenarios where there is a larger amount of data and higher timeliness requirements. Huawei enables car OEMs to provide warning of thermal runaways based on device cloud AI collaboration 24 hours in advance, with a fault coverage greater than 90% and a false positive rate less than 0.1% per month. Trend 6. PV plus ESS and grid integration. Clean energy has become an inevitable trend for the next 30 years. Major regions around the world have proposed development plans for the next 5 to 10 years. Power generation-wise, the PV and ESS clean energy bases in areas with abundant sunshine can generate power and transmit power to load centers through UHV, which will accelerate the cross-region construction of UHV grids and enhance power distribution and interconnection. Consumption-wise, distributed PV, ESS, and controllable loads are combined and the distributed power generation and storage units are flexibly scheduled to enable user-side adjustable resources to participate in market trading and load-side response, balancing peak loads. This has become a new business model. Therefore, the integration of PV-ESS and the grid will become the key measures to ensure energy security and energy supply. By integrating digital power electronics and energy storage technologies, intelligent scheduling and multi-energy complementarity becomes possible. We can also build an intelligent O&M platform to reduce the required manpower on site for a gigawatt-level clean energy basis. Using 5G, AI, and cloud technologies, the massive distributed PV-ESS can be intelligently managed and operated and participate in power trading. Virtual power plants are created, which provides a strong technical guarantee for users-side adjustable resources to participate in market trading and load-side response and peak load leveling. In 2022, the 1 gigawatt PV power plant with the largest installed capacity and highest elevation, jointly built by Yalong Hydro and Huawei, started construction. It's expected to be connected to the grid in 2023. Solar hydro hybrid power supply becomes possible through multi-energy complementarity and fluctuation reduction. Power utilization is also improved by leveraging hydropower plants' distribution channels. In Europe, along with the trading of wind and solar power, VPP, a profit-sharing model, is now quite mature. By 2022, well-known VPP operators in Europe have managed over 10,000 distributed power generation systems, including hydropower stations and wind power stations. The overall load exceeds 10 gigawatts. Trend 7. Upgraded safety. The safety of PV and storage systems is the cornerstone of industry development. This requires us to consider safety issues from end to end and fully integrate power electronics, electrochemical, thermal management, and digital technologies for upgraded safety. First, DC site safety. The application of SSLD tag and SCTD tag in PV power plants can reliably break common faults on the DC side, such as component reverse connection, backfeed, thermal overtemperature, and inverter bus short circuits to reinforce safety. Second, distributed roof safety. Fires caused by arcs present the biggest risk in this scenario. Therefore, equipping inverters with arc fault circuit interrupters has become a common requirement. Thailand, Brazil, and other countries have released relevant regulations. In addition, the high voltage under light conditions is another safety hazard, which poses risks to maintenance engineers and may cause delays in fire rescue. Therefore, rapid shutdown of modules have become a must. Third, ESS safety. In recent years, ESS accidents have become a problem we can't afford to ignore, holding back the safe development of ESS. The core of ESS safety design lies in the DC side. Many batteries are connected in series or parallel, posing challenges to systems monitoring, control, and fire safety. With advanced digital technologies such as power electronics, cloud, and AI, accurate and reliable monitoring and management from the system to the cell is the key. ESS needs to go from reactive response and physical isolation to proactive automatic protection and early warnings, and implement multi-dimensional safety design covering hardware and software, structures, and algorithms. In this ESS project, to ensure safety, SmartStream ESS with 4 levels of active shutdown is adopted, providing comprehensive protection from packs, racks to the whole system, and ensuring the system's safe and reliable operation. Trend 8. Security and trustworthiness. As PV power stations move from megawatt to gigawatt, security and trustworthiness becomes increasingly important. Network information security of power stations needs to be considered at the equipment level and system communication link level. In the face of external cyber attacks, the power station system must prevent unauthorized access, protect privacy and sensitive data, and ensure that information is not tampered with or damaged by unauthorized personnel. However, such reactive security strategy is not enough given the complex and fast-changing network environment. We need to go beyond security and achieve resilience. For example, real-time adjustment of intrusion detection policies are needed, which helps power plants identify and quickly respond to security incidents. Countermeasures need to be available to quickly recover damaged functions or services and ensure service continuity. In addition to reliability, availability, security, and resilience, a PV power plant system also needs to prevent harm to humans and the environment and protect privacy. In the future, reliability, availability, security, resilience, harmlessness, and privacy will become the essential requirements of PV systems. Trend 9. Digitalization. Various industries are facing digital transformation. Throughout history, societal advancements often come along with energy revolutions. We're now at a stage of building the next generation power system, with new energies being the largest source. This also presents considerable opportunity of commercializing digital technologies. Traditional PV power plants have a large number of devices, but lack information collection and reporting channels, so they are basically dumb devices. In addition, power plants are siloed and management is coarse-grained, if there is any management. If advanced digital technologies such as 5G, IoT, cloud computing, sensing, and big data are introduced, PV power stations can talk to one another and be good at it. That way, we can manage watts with bits, so that power generation, transmission, storage, distribution, and consumption can be made visible, manageable, and controllable, ushering in a digital era featuring intelligent O&M systems integration, multi-energy complementarity, and efficient power generation. The Huanen Dongfang power plant is a pioneer of digitalization in the PV industry. Many PV power plants around the world are undergoing digital transformation. It's estimated that more than 95% of the world's power plants will be fully digital in 2027. Trend 10. AI application. As the energy industry becomes more data-driven, the amount of data generated by power plant equipment will increase exponentially. How to better collect, utilize, and maximize the value of data has become one of the most important topics for the industry. AI technologies are being commercialized in various fields, including finance, healthcare, manufacturing, education, security, and energy. AI technologies can be widely applied to the new energy field, featuring high volatility and uncertainty, and play an irreplaceable role in the entire life cycle of PV plants, covering manufacturing, construction, O&M, optimization, and operation. PV module manufacturers using AI-powered quality inspection methods see the production efficiency improved by at least 10%. The AI-powered intelligent IV diagnosis technology can be widely applied to the O&M of power plants, especially in large bases in remote areas. The fault locating efficiency can be improved by 20 times. The Malaysian company, Asia Meranti, has a 30-megawatt power plant. Intelligent IV diagnosis can be annually used to save more than 2,000 hours of manual labor. The industry is also experimenting with intelligent IV and CV converged solution, which can increase the component fault locating efficiency by 4 times. For household power plants, AI-based PV and ESS application can generate optimal power control by using intelligent algorithms based on power generation and load prediction data, thereby improving the owner's comprehensive operation yield by over 8%. We believe that AI provides a solid foundation for the massive data required for deep learning and will quickly become the cornerstone of innovation in the energy industry. AI, cloud computing, big data, and other technologies are increasingly converged, and the tool chain around data processing, model training, deployment, operation, and security monitoring will be more enriched. AI will bring about a profound transformation in the new energy field, just as power electronics and digital technologies will do. These are Huawei's observations on the top 10 trends. Looking forward, the convergence of 5G, cloud, and AI is leading to a world where everything is sensed, connected, and intelligent. The transition is faster than we have expected. By identifying the top 10 trends of the PV industry, Huawei envisions a green and smart world within our reach. We hope that this may spark more ideas from industry colleagues and all organizations and individuals who care about sustainable development. Let's work together towards a low-carbon and green future. Thank you, Mr. Chen Guoguang, for your wonderful presentation. We all look forward to a green and intelligent world and the coming innovations in technology. Developing insights into industry trends helps us seize opportunities. With innovations and its understanding of industry trends, Huawei Smart PV is ready to embrace opportunities and challenges, with PV to become the main energy source and build a green future with all of you. Distinguished guests, that brings us to the end of the launch of the Top 10 Trends of Smart PV 2023. Thank you for your participation.